So we start another program of array but using pointers. So let us take that program that there is an array A, there will be another array B, and A and B added together will give you C. So it's very simple, A and B added together will give C, that is elements of A plus the elements of B will give you C. I mean to say like A is an array containing 5, 7, 9, 3, 8, 12, 2, and B is an array containing 4, then 3, then 7, then 2, then say 13, then say 29, then say 6, then say 8, then say 14. So it is not necessary that the number of elements in A and B are same. Now what will be C? C will be the addition result, 9, 10, then 9 and 7, 16. How am I getting it? 5 plus 4, 9, 7 plus 3, 10, 9 plus 7, 16. So next 3 plus 2 should be 5, then 8 plus 13 should be 21, 12 plus 29 should be 41, 2 plus 6 should be 8, this is 8 itself, this is 14. Isn't it so? So this is what the program is all about. So what you need to do is, you need to add the elements of the array as long as the number of elements of the lesser sized array is reached. After that you just need to copy the other array's elements. So how to do that? We will do it using pointers. So firstly you know that I need 3 pointers over here, int star A, star B and star C. Why 3 pointers do I need? Because A, B and C are 3 arrays. I will declare 3 pointers and then allocate the sizes using malloc. So firstly I will ask from the user, enter the size of first array. So printf enter the size of first array. So you get it, enter the size of first array. That is what I will ask from the user. So user is expected will enter the first array size. So or you can ask for the 2 array sizes together. Enter the sizes of the 2 arrays, that way I can do. Enter the sizes of the 2 arrays to be added. Is not so? That can be done togetherly. I want the sizes of the 2 arrays and I scan those as sizes of A and B. So over here a /n so that the user enters in the next line. So definitely scanf. What will I need? %d because sizes are both integers, and then maybe one size in M and one size in N. Is not so? So once this is done, I know that M is the size of A array, N is the size of B array. So what will I do? Once this A and B has been declared, till now the initial address has been declared. That is the address where the first element will stay has been declared. But I will need to allocate the memories for the other elements, and once I do that, after that I will receive that in the corresponding first pointer. Is not so? So first and foremost malloc is needed. Where will I receive it? Say in A equal to, so malloc is definitely needed. Malloc, what is the size of A? M. So M into size of integer, M into size of, you remember the size of operator, size of int, because after all I will be receiving integers within this. So A equal to malloc M into size of int. But what is A? A is a pointer to an integer in star. So definitely before receiving it in A, I will typecast it to int star and then receive. So A equal to int star malloc M into size of int. This is absolutely correct. B is equal to int star malloc. Same thing, but this time n into size of int. n into size of int, because size of B is n, B array is n. Now what about C? What will be the size of C array? See, the size of C array over here appears to be equal to the size of B. But that is because B array size is larger. Had A contained 3 more elements, which you don't know, user will know. So those 3 elements would have made A's size bigger. In that case, C's size would have been equal to the size of A. What I mean to say is, or what it points to is, that the size of the bigger array should be the size of the C array. Size of the bigger array out of A and B should be the size of C array. Is not it so? So definitely I need to check over here if M greater than N. If M greater than N, what you do is you use smaller size and bigger size, 2 integers. Smaller size is equal to N. What I mean to say, I receive this in a variable called smaller size. If M is greater than N, then smaller size is equal to N and bigger size is equal to M. Is not so? If M is greater than N, what is the size of the bigger array? That is M. So bigger size is equal to M and smaller size is equal to N. That you are doing because you want to get the bigger size, because the array of C array size should be equal to the size of the bigger array. So you are copying that bigger size in bigger size variable, so that you can actually allocate C equal to int star malloc bigger size into size of int. The bigger sized array should be the size of the C array. Is not it so? You need to do an else part also. The else part is the reverse. That is, in the other case, smaller size will be equal to M, or else, and bigger size will be equal to N. Just the reverse. Okay, so this is done. You can, this is done. Now, C, what will be the size of C? C will definitely be int star malloc bigger size into size of int. I think you understand this. This is quite clear for all of you. C equal to int star malloc bigger size into size of int. So that is the size of C, the bigger sized array. Now you know one thing, that for the smaller size, whatever is the smaller size, up to that smaller size elements will be added. See, this is the smaller size. So up to smaller size the elements will be added. Then from smaller size to bigger size, the bigger sized array elements will be copied. I repeat, up to the smaller size, A and B arrays will be added to get the elements of C. Then from smaller size to bigger size, that is the rest of the elements will be copied from the bigger sized array. So what to do over here? Firstly, I need a for loop for the addition. For I equal to 0, I less than smaller size, I plus plus. What will I do? I will add. How to add? Ci is equal to Ai plus Bi. Is not it so? I can do Ci is equal to Ai plus Bi. I could have written it using pointers also. I could have written like this, that is star of C plus I is equal to star of A plus I plus star of B plus I. I could have written like that also, that is possible. However, I am only writing Ci is equal to Ai plus Bi, because that is also possible. Ci and star of C plus I are same. You have seen that. So this is the addition. The addition is very simple, very very simple. Now what about the rest part? For now, see, up to smaller size you have added. A and B have been added to get the elements of C. So for I equal to 0, I less than smaller size I plus plus, Ci equal to Ai plus Bi. Now for the rest of the elements, for I is equal to smaller size, you start from I equal to smaller size, then go up to I less than bigger size, and then go up to I plus plus, and go I plus plus. What will you do now? You will now copy from which array? A array or B array? The smaller sized array. So the smaller size is there in the variable smaller size. But which array is the smaller sized array? Do you know that? You don't know that? See, try to understand this. Up to less than smaller size you have added. See over here. From I equal to 0 to I less than smaller size. That is, in this example, up to the number of elements of A you have added. Then from I equal to smaller size, this element, that is maybe n, you can think like that. From this array to the rest of the array, what are you going to add? What are you going to do? You are going to copy. But copy from B or copy from C, that you don't know. Because you know smaller size variable contains the smaller sized number. Whatever is the smaller size, that is there in the smaller size variable. Whatever is the bigger size is there in the bigger size variable. But what about the array which is bigger in size? So Ci will you copy from A, the rest of the elements of A or rest of the elements of B? That depends on who is bigger. So can we do one thing? We know if AM is greater, then you enter this. AM is greater means who is bigger? A is bigger because AM is the size of A array. AM is the size of A array. So you enter this if means definitely A is bigger in size. You enter this else means definitely B is bigger in size. So can I do one thing? I use bigger sized array a pointer called bigger sized array, and make A, copy A, the pointer, the address A. Definitely A is the array means A is an address, the starting address of the A array. I copy that in the bigger sized array variable. What should be the nature of what should be the data type of the bigger sized array variable? It should also be int star. What I mean to say is, I declare another array called bigger sized array. Another pointer called bigger sized array, not array, let us call it pointer. Another pointer called bigger sized array. Now what I am doing is, if A is bigger in size, M is greater than N means size of A is greater than size of B. So if A is bigger in size, I am copying that variable, that pointer, the starting address of A, I am copying it to the variable called bigger sized array. Similarly, if B is bigger in size, I will copy the pointer B, that is the starting of the B size B array, starting address of B array, that I copy in a variable called bigger sized array. Bigger sized array is a pointer variable. Now I know I can copy the elements of the bigger sized array. I can copy the elements of the bigger sized array to the elements of C, to the rest of the elements of C. So see, AI and BI added initially up to smaller size. Then for the rest of the elements, I copy the bigger sized array variables to the rest of the C variables. So now you know that C is containing the sum for the first few elements, and for the rest elements, which is for the bigger sized array, you have copied. So C contains all the elements now. I think you understand this. This is something I have done. I have just copied one pointer to another pointer and done a new thing, maybe you can call it. Now once C is ready, now your only job left is to print the elements of C. So printf the added array is, the elements of the added array are, rather, the elements of the added array are. What are the elements of the added array? That is the elements of C, isn't it so? So colon slash n, and now I will print the elements of C. For I equal to 0, I less than what? I less than bigger size. Up to the bigger size you print, you don't know what is the size of C. You only know the size of C is this. C equal to bigger size. See, you have malloc with C bigger size. So bigger size is the size of C. You don't know which one, A's size is the bigger size or B's size is the bigger size, that you don't know. But you know bigger size variable contains the bigger size. Whichever is the size of A or B, whichever is bigger, that is the bigger size. So for I equal to 0, I less than bigger size, I plus plus, you will print Ci, printf %d followed by Ci. So the elements you have printed, you can give a bit of gap and then print. So this thing is printed now. Now you can say that all the elements, if all the elements have been added and you are printing it. So this much is the program. You can now run it. Only thing is declare. You did not declare m. You did not declare n. You did not declare smaller size. Let us do all this. Smaller size. I need to declare bigger size. All these are integers. Smaller size, bigger size, all these are integers. See. So smaller size, bigger size, m, n, everything declared, bigger size array declared. I did I declare? No, I did not declare. So yes, I. What else? M, n you declared, nothing else? Okay, so I have declared most probably everything. Let me run it once and see. Or did I comment out the first portion? No, I did not. Let me comment out. This portion I actually had written to explain to you. So what is the program? So commenting out this portion. So now let me run it. Alt R, enter. No errors. Enter the sizes of the two arrays. Maybe 3 and 5 are the sizes of the two arrays. So you did not do one thing. You did not ask for the elements of A and B. See, while I was hurrying up, I did the entire program but never asked for the elements of A and B. I have simply added, but what are the elements of A and B? I did not ask that from the user. See, I have added the elements. I have just mallocked the array and then mallocked the two arrays, mallocked the C array and then added everything, but I did not ask for the elements of A and B. So because by default it contains 0, so everything has been added and 0 has been printed. It's not so. See, like this. If you say 3 and 5, it has printed 5 zeros because the elements of A by default were 0, elements of B by default were 0. So first 3 zeros were added, then the last 2 zeros were copied. So it showed all zeros. The numbers were not asked for. So it is better before you add, you ask there. Here I can ask. Now printf enter the elements of the first array. The first array contains how many elements? M number of elements, because first array is A. You have just scanned it in M. So A is the size of M. So is the first array. You can write enter the %d elements of the first array. %d elements of the first array. /n is needed. So %d, what is this %d? M, and then you need to say, you need to scan it. So for I equal to 0, I less than M, I plus plus, you can scanf %d. Where to scan it? Ampersand AI, or you can write only A plus I, that is also possible, A plus I. So you scan the elements of A. The %d elements will be entered by the user, M elements will be entered by the user. So M elements you scan and put it in the AI variables of A. Similarly, you need to do the same thing for B. Let me copy paste. I'm just copying it so that I can paste. I copied it, now to paste. I have pasted it. Now enter the %d elements of not the first array, but this one is for the second array. Enter the %d elements of the second array, but this one is n. The number of elements of the second array is n. So this %d has to be replaced by n. And here the counter should go from I equal to 0 to I less than n. And A plus I, not A plus I, but B plus I, because I am now scanning the elements of B array. This time it should work fine. Let me run it again. Enter the sizes of the two arrays, 3 and 5. Enter the 3 elements of the first array. So 4, 9, and 12. Enter the 5 elements of the second array: 8, 18, 64, 2, 39. So what should be the answer? The elements of the C array will be 3 and 8, 11, 5 and 9, 14. Sorry, 5 and 9, yes. 3 and 4, 7. I'm sorry, 3, no, I'm just making a mistake. Very sorry. 4 plus 8, 12, 9 plus 18, 27. So 4 plus 8, 12, 9 plus 18, 27, 12 and 64, 76. Then 2 and 39. So see, 12, 27, 76, 2 and 39. 2 because 4 plus 8 is 12. 27 because 9 plus 18 is 27. Then 76 because 12 plus 64 is 76. And 2 and 39 is left out. 2 and 39 are left out, so they have been printed. So the elements of the added array are this. So I think to understand this, let me run this program once more. This time maybe the 7 is the array size of the first one and 4 is the array size of the next one. So 7 elements of first array: 4, 19, 28, 93, 3, 6 and 12. Enter the 4 elements of the second array: 4, 9, 16, 72. So you check out, 4 and 4 makes it 8, 19 and 9 makes it 28, 28 and 16 makes it 44, 93 and 72 makes it 165. Then 3, 6, 12 left out, so they are copied. 3, 6, 12 are the extra 3 elements of the first array. So I think you have understood this. As I told you, you come back after a bit of break. When you come back, we will do one more program with arrays, and that will be a very interesting program, that is sorting the elements of an array. Say 6, 8, then 2, then 12, then 11, then 19 is written. Then say 5 is written. You will have to convert and make this array sorted. Sorted means 2, then 5, then 6, then 11, then 8, then 8, then 11, then 12, then 19. The elements arranged in ascending order. That is what we will do when we come back. That will be one more example with arrays, where we will be using pointers to do it maybe. So we will learn that. After that, we will be learning relation of 2D arrays with pointers. So we will come back. Thank you so much. You can take a bit of break. We will come back.